Hi everyone, welcome to today's tutorial. So in this tutorial we're going to look at how we can solve questions, or how we can integrate using integration by parts. Alright, so if you have not yet subscribed to the channel, make sure that you click on the subscription button, and you should also click on the notification button so that you don't miss out the videos that I'm going to be posting. And then if you have any questions, or you need help, or you need tuitions in mathematics, chemistry or physics, feel free to contact me on any of these contacts on the screen. Okay, so let's quickly begin to solve. Alright, so this is the formula for integration by parts. This is the formula. And then the first question is the integral of x squared sine x. So the first thing that you need to put in mind when you are solving questions using integration by parts, when you're integrating using this formula, there is a mnemonic word that is called liet. Yeah. So you need to put this in mind. You need to know this. So L stands for logarithmic functions, I stands for inverse trigonometric functions, and then A stands for algebraic functions, and then T stands for trigonometric functions, and then E stands for exponential functions. Alright, so these are the ones that we take as our U. Yeah, so as you can see in this formula, there is U, dV, there is also U, there's also V there, there's also du there. Yeah, so the way you know which one you're going to take as your U is by following this mnemonic word. Okay, so let's quickly begin to solve. So if we take, for instance, this question here, our U is going to be A, because A comes earlier than trig. So A is algebraic, so our U is going to be A. So this is what we're going to get as our U, because it comes earlier than the trigonometric function, which is sine. Okay, so I'm going to take my U as, so I'm doing this. So this is the question I'm solving. I'm going to take my U to be equal to x squared. So immediately after doing this, it means that, or if I take my U as this function here, it means that the remaining part will be taken as dv. So what I mean is this. So let me write it here. So if I take, in this question, for instance, I've taken U to be x squared, meaning the remaining part is going to be taken as dv. dv will be equated to sine x dx. Alright, so having done this, we can now differentiate this part. So differentiating U with respect to x, finding du dv, du dx, finding du dx, we're going to get 2x. So in this, so now after doing this, I think we can leave this here. Then we can also find v, because we know there is v there, but we don't have v in this expression. So how do you find v? It's by integrating this function. So if we integrate dv, we're going to get v, and then if we integrate sine x with respect to x, we're going to get negative cos x. Yeah, so if you integrate sine x, you're getting negative cos x. Yeah, so now we can use the formula. So while there is, so the formula says that the integral of u dv is equal to uv minus the integral of v du. So I'm going to, so in other words, the integral of this expression here is simply just equal to, okay, let me do this. So my u here is x squared, so I'm going to write x squared, and then v, I've found v to be negative cos x, so negative cos x. Then we write this minus there, and we say the integral of v, so v is negative cos x, and then du, which one is du? So du is going to be found by making du the subject in this expression. So if we make du the subject, we're going to have something like this. Let me just write small things here so that you know what I'm trying to write. So du dx was found to be 2x, so du will simply just be equal to 2x dx if I cross multiply here. So du there, I'm replacing it with 2x dx, then plus c. So now we can simplify the expression. So the next step is simplifying the whole expression here. So we have x times cos x, we're getting negative x squared cos x. Then this negative x times that times 2x, we're getting positive 2. And of course I'll just factor out the 2 in advance, so I'm just going to remain with x cos x there, then dx, then plus c. So I'm also going to integrate this part alone. So integrating this part alone, let me take it here. So integrating this part alone, I'm going to take x as my u. So u is equal to x, meaning du dx will be equal to 1. So du will simply just be equal to dx. Then I'm also going to take my dv to be equal to cos x dx. So if I take that, then I'm going to find v by integrating both sides. So my v will therefore be equal to differentiating cos, rather integrating cos will give me sine x. Okay, so I can replace it in this formula. So my u is equal to x, and then v is equal to sine x, then minus the integral of v is sine x, then du is equal to just dx there, so we put dx there. So finishing up this will give us okay, let me write it this side. So finishing up this will give us x sine x, to give us x sine x minus, then this part here will give me, when you integrate sine x, you're getting negative cos x. So you're getting negative cos x, so I'm going to have negative cos x there. So when you combine negative and negative there, you're getting a plus, a positive, so there's a plus there. Okay, so this is our expression for this one. So now our final answer will be found by replacing this this answer that we found here, replacing it there. That's going to be our final answer. So this is now going to be so the final answer is now going to be equal to negative cos, negative x squared cos x, and then of course there's a plus there, so we're going to have plus 2 open brackets, then we'll replace that of x sine x plus cos x, and then we have plus c this side. So here it's just a matter of multiplying 2 times this, 2 times x. So what I mean is this negative x squared cos x plus 2x sine x, then plus 2 cos x, then we have plus c. So this is the final solution for this integral here. Let's quickly move on to the next one. So the next one, even in this case, we're going to follow the same harmonic word, which is liet. So lin comes earlier than algebra, so we're going to get u to be a logarithmic function, which is a ln function in this case. So my u is just going to be equal to ln x. Du dx will give me 1 over x. So when you differentiate ln x, you're getting 1 over x, meaning du will simply just be equal to dx over x. Then apart from that, our v will therefore be equal to x to the power 5. This is going to be our, our dv. dv is simply just going to be equal to, so dv is going to be equal to x to the power 5 dx. Then we can integrate both sides to get v. So v is going to be equal to x to the power 6 over 6. Yeah, and then from there we can now apply the formula. So my u is equal to ln x, then I'm multiplying it with v. v is x to the power 6 over 6 ln x, then we say minus the integral of v is x to the power 6 over 6, then du is dx over x. This one is supposed to be x. So when I multiply these two, I'm going to get so let me copy this. So when I multiply these two, I'm getting x to the power 5 over 6 dx. So integrating this part, I'm going to get okay, let me copy this first. So this will be x to the power 6 over 6 ln x, then minus, integrating this part, I'm going to get x to the power 6, but of course 6 times 6, I'm getting 36 down, then plus c. So this is the final answer for this integral. Let's quickly move on to the next one. So the next one is this one. So this one, the process of finding this integral is quite long. So it's actually in two forms. There's also another one which has sign here. So it's quite long. If you need the process, or if you need the whole procedure, you can text me on WhatsApp, and then I'll send you the link where I have solved for both cos and sine. But otherwise, there's a short form of knowing or integrating this. So if you have anything, like if you've been taught to integrate anything that is in the format ax, then cos 3x, this one, oh, not really 3x. If you have anything that is in this format, you simply just say, or you simply just have to replace the values of a and b in the following formula. This formula I'm going to write. Yeah, so this is what you're supposed to do. Yeah, so and then you put plus c this side. Okay. So this is how you're supposed to do it. So in this case, the value of a is simply just 2. So I'm going to replace 2 others a. So I'm going to have e to the power 2 x, and then everything will be a squared plus b squared. So my b is 3, my a is 4. So rather my a is 2. So 2 squared will give me 4 plus, and then okay, let me write it so that I don't confuse people here. So I have 2 squared plus 3 squared, then my b is 3, and then I have sine 3x plus 2 cos 3x, then plus c. So here it's just a matter of simplifying. 2 squared is 4, 3 squared is 9. So we're going to have something like this as the final answer. So this is supposed to be in brackets. Even here, supposed to put this in brackets. So this will be 4 plus 9, that will give you 13. So we have 1 over 13 e to the power 2x, then open brackets, you have 3 sine 3x plus 2 cos 3x, then plus c. So this is the final answer. Otherwise, deriving this formula is quite long. So if you need a question, rather a video where I derived this formula, you can simply text me on WhatsApp. I'll send it over. Okay, so this is the shortest form of solving it. So in case you have sine there instead of cos, this is the formula. So for sine, if you have the integral of e to the power ax sine bx, the solution will be a sine bx minus b cos bx, then everything divided by a squared plus b squared, and of course this is supposed to be multiplied by e to the power ax. Let me write it properly. So what I mean is e to the power ax, everything over a squared plus b squared, then in brackets we have a sine bx, then minus b cos bx, then plus c, of course, if it's an indefinite integral. Alright, so this is for sine. Okay, let's move on to the next one. So this is the other question that we have. So even this one, using integration by parts, you're going to choose which one is going to be your u using Liet. So in this case, my u is going to be x. Algebra comes first than trigonometric function. So my u is going to be equal to x, meaning du dx becomes 1. When I cross multiply, du is equal to dx. So dv also becomes the remaining part, which is sine squared x, meaning to find my dv, to find my v, I have to integrate both sides. But of course, when I want to integrate this part, I have to use some trigonometric identities. So dv is equal to, let me change this part. Before I even integrate, let me use the trigonometric identity of this, of sine squared x. But we know to say cos 2x is given by, know that cos 2x is given by sine squared x plus, minus minus cos squared x. Not really sine, we start with cos. So we have cos 2x is equal to cos squared x minus sine squared x. So here I'm looking for sine squared x, so I'll find means by which I'm going to get rid of this cos, because there's also what is known as the Pythagorean identity, which is sine squared x plus cos squared x is equal to 1. So I'm going to make cos squared x in this equation as the subject, so I'll take sine squared x to the other side. So I'm going to have sine squared x is equal to cos squared x, supposed to be like this, 1 minus cos squared x. I'm trying to get rid of this, so I'll make cos squared x the subject. So cos squared x will be 1 minus sine squared x. So I'm going to replace this here. So my cos 2x will now be equal to 1 minus sine squared x. Then we have this negative sine squared x. So meaning cos 2x becomes 1 minus 2 sine squared x, and then I'll take this one to the other side of the equal sign, so that it becomes, or rather, let me just make sine squared x the subject. So sine squared x, the subject of the formula, is going to be 1 minus cos 2x, but of course everything in brackets, and then we have 1 over 2 this side. We divide everything by 2. So this is what we're going to replace there. So we'll have 1 over 2, open brackets, 1 minus cos 2x. So to find v, I'm going to integrate both sides. So my v will become 1 over 2, then open brackets. If I integrate this with respect to x, of course this side is supposed to be the x. If I integrate this side, if I integrate this 1 with respect to x, I'm going to have x there. If I integrate this part with respect to x, I'm going to have, if I integrate 2x with respect to x, I mean cos 2x with respect to x, I'm going to have sine 2x, and everything divided by 2. So this is what I'm going to get. So this is my v. So I can replace this v where we didn't even start solving. Alright, let us now start solving the question, this one. So u is there, so u, the value of u we said is x, so we put our x there, and then v is simply just this expression there, so I'm going to write it. So I'll do this, 1 over 2, then open brackets, we have x minus sine 2x over 2. Then we say minus the integral of v, which one is v, so this is v, and then du we said is just the same as dx. This is what we found there. So the integral of, so I'll remove the half this side, this half, then I'll remain with x minus sine 2x over 2, of course dx. So we can now find the final solution for this expression. It's supposed to be c this side. So the final solution for this expression is going to be 1 over 2x, open brackets, x minus sine x over 2, then minus, we can now integrate this, so we have half. So when I integrate x, I'm getting x squared over 2, then minus, when I integrate this part, I'm getting, when I integrate sine x, when I integrate sine x, I'm getting negative cos, I'm getting negative cos 2x. If I integrate sine 2x, I'm going to get negative cos 2x, and then since it's going to be negative, it's going to multiply with this negative here, meaning we're going to have a plus there. Then this will become cos 2x. Then of course, since there's this 2 already, if we divide by another 2, we're going to have a 4 there. Then we say plus c. So this is the final answer. If you want, you can simplify it further by multiplying half times everything that is in the brackets there. Alright, so this is how simple these questions are. Let's quickly move on to the next one. Okay, we look at this one. This one, you don't need to apply integration by parts when solving this one. You apply what is known as u substitution. So using u substitution on this one, we get a function between these functions that we've been given, which when we differentiate it, it's going to cancel with another function. Okay, so What I mean is that if I choose my u to be sine x, because I know that if I differentiate sine x, I'm going to get cos x. So if I make dx the subject, I'm going to have du over cos x in this expression. Okay, then from there I can replace back everything that I have assumed to be here. So I'll replace u while there's sine x, so I'm going to have the integral of cos x, then e to the power u, then while there's dx here, I'm going to replace du cos x, so this will be du over cos x. So you can see that this cos x will cancel with that cos x, meaning we're just going to remain with the integral of e to the power u du, and then when you integrate this, you're going to get e to the power u and plus c. So meaning the final answer for this expression is simply just going to be equal to e to the power, of course the value of u there is sine x there, so we can replace it back, and then plus c. So this is what we have as our final solution. So let's quickly move on to the last part. So the last part we are going to use integration by parts, but of course we need to also consider Lie. We need to also put this into consideration. Alright, so algebra comes earlier than the exponential function there, which is e. So we get x as our u. So we say u be equal to x, and then from there du would be equal to dx. You differentiate and then make dx the subject of the formula. So in other words, what I'm trying to say is this: u is equal to x, then du dx is equal to 1, and then dx becomes what? Oh, rather du becomes x. So du is equal to dx. Of course we used Liet, it was written here. So from there you can now replace in the formula. Oh, by the way, let's find v. So we know to say the remaining part will be considered to be dv. So dv is now going to be equal to e to the power x dx. So if we integrate both sides to get v, we discover that our v will simply just be equal to e to the power x. So we can now replace in the formula there. So in the formula, if we do the replacements there, we're going to get so my u is x, and then v is e to the power x, and then I have minus the integral of v. My v is e to the power x, and then du, my du is equal to dx, so I'm going to write dx there. So integrating this part, I'm going to have e to the power x as the answer if I integrate this part with respect to x. So plus c. But if you look at this one is a definite integral, so there's no need of us adding c. So we just need to put in the limits. So the limits we have are infinite and 0. So even there we have infinite and 0. So if we place the limits into the expression, we're going to have, so if we put the infinite symbol while there's x there, this is going to give us so to make our work easier, we can just say the expression here is just this part here. If we put the infinite symbol into this expression, this is just the same as the limit of finding the limit of x e to the power x as x approaches infinity. And then if you put infinity here, what are we going to have? I think we will still have the same thing. So let me just write it this way. I'll put it like this, minus e to the power x, and then we say minus, we now plug in 0, we put the lower limit. So if we put 0 there, the whole part here will become a 0. And then if we put if we put 0 there, the whole part here will become a 0. If we put 0 there, this will become a 1. So this part will become a 1. So we can do that. So this is, I think, the expression, the final answer. Okay, so here, like I said, this is just the same as the limit. When we are replacing infinity, it's just the same as the limit of the whole function here, this part, which is the integral, as x approaches infinity. Okay, so this is that part, and then the other part is this. When you replace 0 in this expression, you get it in 0, and we say minus, but because there is a minus here, and there's also a minus that is found between the two limits when you're replacing, meaning this part was supposed to be a 0, rather it was supposed to be a plus. Okay, so this can also be simplified as the limit as x approaches infinity of x e to the power x minus e to the power x least plus 1, like that, still the same. So this is how you can write it. So this is the final solution for this expression. Alright, so if you have any questions, feel free to contact me on the lines that you can see on the screen here. Then if you have not yet subscribed, click on the subscription button and the notification button so that you don't miss out the videos that I'm going to be posting. My name is Hamted. See you in the next tutorial video. Shalom, shalom.